Hi guys, this is Akash Chaudhary. Welcome back to my channel. Let's talk science. Today, as you can see, we'll study about work, power, energy. However, on this video, we'll only study about work. Then we'll go to power and sequentially we'll reach to energy. So let's start about work the way we do from its definition. So here comes the definition. So what is work? Basically, work is said to be done by or against a force. So imagine whenever there is an object, suppose there is a box placed on the ground, you apply a force. That is, you push the box. The box will get pushed in the direction of the force that you have applied. Then we can say that the work has been done. Now come to the second point. When its point of application moves in the direction of the force. That is, when you are applying the force, the box is moving in the direction when the force is applied. Suppose there's a box. You are applying the force on the box from your left hand in the right direction. The box is obviously moving to the right. That means on applying the force to the right, the box is moving to the right. This justifies this point, when its point of application moves in the direction of the force. Now let's come to the third point, that is how it is measured. Just try to understand this first. We'll be going through each point individually. How it is measured? It is the product of the force applied and the displacement. That is, it is the product of the force, the magnitude of the force and the displacement from its initial position to the final position. You will understand this with a diagram. Yeah, suppose this is the diagram. Suppose this is the box. You have applied a force here. The box or the cylinder, here it is a cylinder. The cylinder moves from this position to this position. So what is the displacement? This is the displacement, that is denoted as S. And what is the force? F. So from the previous slide, what we know, that it is the product of force and the displacement. So we can see that what is work? It is the product of force, magnitude of force applied, and the displacement of the body from its initial position to the final position. So here we can see the quantitative formula of the work. What is work? As we know that work is the product of force and displacement. Get it right into your head. What is work? Work is the product of this magnitude of the force and the displacement of the body in the direction of the force. That point was very important, in the direction of the force, because the formula of the work will change if this is not happening. That is, in the direction of the force is not happening, the formula of the work will change. Yes, it will change. It will not remain only W is equals to F into S. We are coming to that. The actual formula of the work. We know that the formula of the work is equals to force into displacement, but that is not the actual formula. The actual formula is work is equals to force into displacement into cos A. Now what is A? A is nothing but an angle. We'll understand what is A in detail. Just understand that what is A here? A is just an angle. Okay. Now force is there, as we have studied in the previous slide. Displacement is also there, as we already know. What is new here? Cos A. And what is A? A is an angle. What angle? What type of angle? Why cos is there? We'll all get to know about it. Okay. But just remember for the time being that work is equals to F into S into cos A. Now, and what is A? A is an angle. Just remember this for the time being. Everything will be clear. So now if someone asks you what is work? Work is force into displacement into cos A. Now let's see what is A and why it is coming into action. Suppose there is a pyramid. This is a pyramid. And you have to put this box at the top of the pyramid here. What will you do? You will apply a force here. Is the box going in the same direction of the force applied? No, it is traveling in this direction. In the definition of work, what we have learned? We have learned that it is measured as the product of force applied and the displacement of the point of application in the direction of the force. In the direction of the force. Now guys, tell me, is the displacement happening in the direction of the force? Force is applied here in this direction. The body should have moved like this, but whereas here the body is moving like this. So is it moving in the direction of the force? No, absolutely not. It is moving in some other direction, even if the force is applied in some other direction. So what is the angle? The angle here is this one. So this one is the angle. That is, work is being applied here, but the displacement is happening in this direction, which is not the direction of the force applied. Sorry, force is being applied here and the displacement is not in the direction of the force applied, but rather it is happening in some other direction. So the angle made between the force and the displacement will be A. And that is why we are writing here cos A. That is, work is equals to force into displacement, as we have seen this earlier, force into displacement. But since there is one more parameter over here, it is cos A. Now the question will arise, why was it work is equals to force into displacement without any cos A when the displacement was in the same direction of the force? So guys, tell me, when the direction was same as that of the force applied, the direction of the body was same as that of the force applied, what was the angle? The angle was obviously 0, right? The angle was 0. So if I put here 0, cos 0, do you know what's the value of cos 0? Let's check it out in the next slide. The value of cos 0 is 1. Since the value of cos 0 is 1, if you apply it here, what will be the value? W is equals to force into S into cos 0. Cos 0 is 1. So in the end, what it is coming? W is equals to force into displacement. That is why we wrote there that the formula, the quantitative formula of the work, if the displacement is in the same direction of the force, is W equal to F into S, because the cos A was 0. The cos A was 1. Sorry. Whereas the actual formula is this. Now suppose if the work is being done in some angle, like this case. So whatever angle is mentioned here, the cos of that angle's value will also be mentioned to you in the numericals, and you just have to put the formula, put the value over here and find the value of W. Now let's go through some values of cos A. Suppose if the angle is 30, that is, if the angle is 30 here, if the angle between the work and force and the displacement is 30, then put the value of 30 over here, cos 30. Now what is the value of cos 30? Let's see. Let's look in the chart. It's root 3 by 2. So we'll write what? W is equals to F into S into root 3 by 2. Simple. If the angle is 45, then what we will write? 1 by root 2. Then we will write W is equals to F into S into 1 by root 2. If it is cos 60, it is half. Similarly, if it is 90, it is 0. This one is interesting. Cos 90's value is 0. That means if the angle between work and the displacement is perpendicular, if it is like this, perpendicular, then the angle will be 90 here. If the angle is 90, I will write cos 90. Now I can see from the chart that cos 90's value is 0. Then the whole work will, the whole magnitude, the magnitude of the work will be what? 0. That means no work will be done if the force and the displacement is at right angle to each other. That is why if a coolie carrying a luggage and carrying a luggage on his head and standing, then we can say that the work done by the coolie is 0. Yes, physically it is 0 because the angle will be 90. Now let's check this one. What is the value at different angles? This part is very important for the numerical. This type of numericals will be only coming where when A is 0, that is when the angle is 0, that is when the work is done, when the displacement is in the same direction as the force applied, the initial one that we did, where W is equals to F into S into cos 0. Since cos 0 is 0, cos 0 is 1, I'm so sorry, cos 0 is 1, so W will be F into S. This is the maximum. If the question comes, state a condition when the work is maximum, then you have to write that when the angle between the force applied and the displacement is 0, that is when it is applied, when the displacement in the same direction of force, then the work done will be maximum. Similarly, in case 2, if A is 90 degree, then we know from the previous chart already that cos 90 is 0. That means if we put the value of 0 here, the work will be 0. I already gave you an example about the pulley standing. Similarly, when A is 180 degree, that is F into S into cos 180, the value of cos 180 is minus 1. You again got one more value of cos 180. Cos 180 is minus 1. If we put it down here, then the value of work will be negative. That is, work done will be negative. Okay. Now this is the maximum work, this is the 0 work, and this is negative work. What does negative work means? Negative work means, imagine a condition, a tug of war. Okay, the winning side and the losing side. One will be a winning side, one will be a losing side. The losing side are applying a force. Okay, this is the force that the losing side applying, and this is the displacement that they are undergoing. But it is minus because the angle is cos 180 degree, because they are losing. The work is done in negative because the positive work is done by the winning side. That is why that is positive and this is negative. So these are basically the 3 cases at different cos angles that we can see the different value of work that we are getting. So from here we are coming to the end of the PPT. I hope you like the video. If you like the video, do subscribe and like and share as much as possible. I'll be coming up with my next video with power and energy. Thank you so much.